Hi, hello everyone. Happy to welcome all participants to yet another episode of Why Not Episode 4 at AGIIT. We have been creating awareness about the need of constantly upskill ourselves and keep in tune with the latest technology in industrial sector. Today, there is an immediate need for everyone, be it student, educator, or employed professionals to stay uh, update the latest technology such as Industry 4.0 to stay relevant. So before we continue, I need to introduce our guest speaker of the day, Honorable Mr. Venkatesh Balasubramanian, Manager, Training and Marketing, SMC India. Mr. Venkatesh is a retired Indian Air Force officer with 21 years of experience in the Mirage 2000 aircraft, aero engine maintenance, aircraft simulation, maintenance automation, aircraft test integration of R-73 missile or Mirage 2000 AC, helmet. So we have a vast experience in defense sector, and he has trained more than 3,000 IIF technicians. He is a Kargil War veteran as well and has been awarded commendations by the Chief of Air Staff in 2016 and by a Air Force Officer Commanding Chief of the Central Air Command in 2011 is the biggest achievement actually. So after taking voluntary retirement, he joined SMC Corporation India. SMC Corporation is a leading pneumatics manufacturer. He is joined the training head. He has worked with several key customers like Maruti Suzuki, Technomet Farm of Nepal, HT Process Control. He is a faculty of Netaji Subhas University, NAIL NBC, and he is also working in Sandan Vikas, NALCO. So he has designed an important curriculum to promote pneumatics learning across several ITIs and universities and skill development institutions in the country. So now I invite Mr. Venkatesh to start this session. Sir, I welcome you, sir.
Thank you very much for this wonderful introduction. It's a great honor to be here today and presenting the webinar on Industry 4.0 and Smart Factory concepts. So without wasting much of time, I welcome first of all the participants who are here to get some knowledge on Industry 4.0 and Smart Factory concepts. So that is wonderful. They've taken out time and they're here to listen to this webinar. So thank you very much once again. So I'll start my webinar. I'll share the presentation. Thank you very much once again. So welcome all of you for this presentation on Industry 4.0 and Smart Factory. So before I begin with the presentation, I would like to tell you about the Ford Model T. I hope everybody has heard about this Ford Model T. When Henry Ford, he said, you can have it in any color as long as it is black. So over 100 years ago, what happened was Henry Ford was sure to have a product market fit. So he knew that the product will sell. Nowadays, it could sound very flashy. But those were the times, it was totally different time 100 years ago. Throughout the 20th century, the manufacturers, they held the authority, on deciding what to place in the market without having actually to cater to the needs and whims and fancies of the customer. But the tables have turned now, and the industry has grown to become customer-centric, from mass production to mass customization. So a new manufacturing philosophy with many surnames like Industry 4.0, Factory of the Future, digitalization, etc. has come up. Today's customer, he will demand individual custom-made high-quality products. The suppliers have to strive to provide unique value to their customers in a very cost-effective and fast way so that they can be more efficient and more competitive. With that perspective, I shall now begin today's presentation. So my presentation is under the following heads. The first is a brief introduction about the SMC Corporation India Private Limited. I shall then delve into Industry 4.0, what business values does it provide, and in case we adopt this Industry 4.0 philosophy, and what technology drivers are there behind Industry 4.0. Then we shall look into some of the skills that are going to be relevant in the smart factory and what changes can we expect when we have Industry 4.0. Then we look at how SMC can help to get smart and flexible. I will also briefly cover a case study on Bosch Rexroth, how they implemented the Industry 4.0 and what benefits they reaped out of it. And finally, before concluding, I will briefly tell you about the SMC Smart Factory Training Kit, which is the SIF 400, and how we train on Industry 4.0 technologies to our engineers. So I will start with a small video on SMC.
From the moment you wake up to the moment you go to bed, SMC is there to help you get through the day. And we have been since 1959. Our goal has always been to bring the future to the present. From pioneering new products that allow for the evolution of things like chip components in cell phones, car assemblies, and food packaging, to making everyday life more comfortable with state-of-the-art products for manufacturing. SMC is changing the world for the better, and continues to do so with new ingenuity revolving around products like 3D printers. But before we were helping make products fit for the Jetsons, we had humble beginnings of just 15 people. At that point in the late 50s and early 60s, we just kept our heads down and focused on the innovative solutions of the time. Things like industrial filters, sintered metal elements, and FRL and silencer. By the 1970s, we expanded our product line with innovations like an aluminum body air cylinder and direct solenoid valves. We also expanded into the UK, Germany, Singapore, and the United States. On top of that, more innovations pushed the future forward. In the 1980s, new innovations in automation, controls, and process technologies were really booming, and SMC's growth brought us into Italy, China, and Korea. This trajectory continued. By the 2000s, more locations kept popping up. Look what SMC has grown into today. And in case you were wondering if you have used products that we help manufacture, the answer is yes. With such a vast array of products and a good global footprint, SMC can help provide a start-to-finish solution and support for your automation needs. SMC, automation, controls, process.
Okay, so I hope that video briefly told you about what SMC does. Before I tell you more about SMC, I would like your attention on this pyramid of automation. Since the beginning of industry, the automation of manufacturing and production process, it has been continuously evolving. This evolution has been made possible due to integration of classic technologies like mechanical and electrical, and with more modern ones like electronics, computer science, communications, etc., which are playing a greater part day by day. This integration of technologies is represented using this pyramid of automation, which includes 5 technological levels which can be considered in any industrial environment. These technologies, they are interrelated both within each level and between different levels by using industrial communication. So the first level, as you can see, is made up of sensors, actuators, and other hardwares, which are the field, which is called the field level. So these are the field level components which will get the information right from the source and pass it on to the higher levels. The second level, or also called the control level, includes logical devices such as your programmable logic computers, your PCs, your proportional integral derivatives, etc. The third level, or the supervisory level, corresponds to control and data acquisition, like your SCADA system. So SCADA basically refers to supervisory control and data acquisition. The human machine interface, which enables monitoring and the issuing of process commands like controller set point changes are handled through the SCADA computer system. Alarm management system is also part of this level. The manufacturing execution system, or MES, is at a higher level, or the planning level. The manufacturing execution system is an information system which connects monitors and controls complex manufacturing systems and data flows on the factory floor. So the main goal of an MES is to ensure effective execution of the manufacturing operations and improve the production output of the factory. And at the top of the pyramid is the enterprise resource planning, or the ERP, which is the management level, which is an integrated management system, which all these things are combined together. So in the subsequent slides, we shall see various technologies which SMC will offer in providing pertaining to various levels of this pyramid of automation. So continuing with SMC, the Indian subsidiary of SMC Corporation Japan, we started off as in an office in Noida in 1995. And from the first factory, which came up in 98, SMC India has progressed steadily over a period of time to become the leader of pneumatic technology in India. We have 4 manufacturing plants, 2 in Noida, 1 in Chennai, and the 4th and the largest plant with an area of 240,000 square meters in Ahmedabad. With 18 branches, 44 resident engineers, and 83 dealers spread across India, we ensure quick one-to-one sales approach, which helps in building long-term relationship with our customers. There are 8 state-of-the-art training centers also all over India, which impart international standard training to our customers. SMC provides innumerable applications of pneumatic control technology, from core industries like automotive and machine tool to diverse industries like food processing, printing, and packaging. SMC has a very strong presence in the automation process in these industries. So from robust and reliable pneumatic components which can work 24/7 and capable of ramping up production and operating in extreme environmental conditions while minimizing energy costs and downtime in auto industry, to high quality precision equipment which meet stringent requirements of no leakage, clean specification, and corrosion resistance are available in the product line of SMC. Right, so now jumping straight into the industrial evolution. The first industrial revolution came about somewhere between 1760 and 1835 in Europe and United States. There was a transition from hand production method to machine and mechanized production, and increased use of steam power was there. The textile industry benefited the most from this revolution and was the first to use modern products. The second industrial revolution, or industry 2.0, it came about between 1870 and 1914, late in the 19th century to early 20th century. In this revolution, we saw telegraph, railroad networks, sewage systems. They saw widespread adoption. Then large-scale iron and steel production, use of petroleum, and beginning of electrification was also seen. An important event was the manufacturing of the first car by Henry Ford in 1896 and founding of the Ford Motor Company in 1903, after which you had mass production which came in. The third industrial revolution, or the industry 3.0, is dated between 1950 and 1970. It is referred to as the digital revolution. This era brought semiconductors, mainframe computing, and personal computing and internet. And traditional productions of business techniques they completely got transformed by the use of computers, microprocessors, cell phones, or what we call the information communication technology, ICT. And finally, the fourth industrial revolution, which takes automation of manufacturing processes to a altogether new level by introducing customized and flexible mass production technology. The machines in this industry 4.0 era will operate independently. They or cooperate with humans in creating a customer-oriented field that can maintain itself. The machine will become an independent entity which is able to collect data, analyze it, and take decisions based upon them. This is known as the Internet of Things, or cyber physical production system. So the term Industry 4.0, what exactly does it mean? What is Industry 4.0? The term was coined initially by the German government in 2011. Although there is no clear definition of this and it is just a buzzword or a concept, it basically refers to the intelligent and permanent linking and networking of machines and machine operated processes. So the key words here are intelligent, permanent linking, networking of machines and machine operated processes in an industry. With the use of modern solutions from the field of digitization, ICT can be used to network people, machines, and the resulting products with each other to achieve greater productivity. So these are some of the synonyms we generally come across when we talk about Industry 4.0, like connected enterprise or smart factory, digital enterprise or cyber physical system, and to name a few. What are some of the business values which we get when we adopt Industry 4.0? What does it bring to our table? So agility, the company becomes agile, or it is capable of rapidly changing or adapting in response to any changes in the market. Cost is reduced by adoption of Industry 4.0, as one knows how much exact amount of raw material is required as an inventory for the production of the finished goods. Waste can be reduced, the risks are minimized, energy can be saved, and therefore you save a lot of cost. The business now begins to innovate. It becomes more innovative. It can develop new products or improve existing technologies, processes, designs, and marketing to solve the problems and reach new customers and thereby increase the profits. Efficiency increases by adoption of Industry 4 technology, which means that the output of a company or a business produces, which it produces for a unit input in terms of capital, labor, and material, it increases. The customer experience with the brand improves, as every interaction of the customer, starting from navigating the website to talking to customer service, product quality, on-time delivery, complaint handling, after-sales service, everything improves dramatically. Revenues increase as economies of scale are very, very high. Enhanced productivity is there, downtime has been reduced, and the quality is improved. So these are some of the benefits that you accrue of Industry 4.0 when you adopt this technology. What are the business drivers? What are the technology drivers or the building blocks? So there are 9 basic building blocks. Big data analytics, which deals with large amounts of data. Data, as you know, is the new oil. It is everywhere and can be structured or unstructured and will be received from many sources like your sensors, your machines, people, customer management systems, your enterprise management system, etc. Collecting, organizing, and analyzing of these large sets of data to discover patterns or other useful information is very important. Amazon, Google, Paytm all use this big data analytics to collect data of the customers, their browsing, buying, and spending patterns. Autonomous robots or independent robots, which can communicate and interact with one another and work safely side by side with human beings. Simulation. Simulation is nothing but mirroring the physical world into the virtual world. Horizontal and vertical integration, which I already talked about while talking about the pyramid of automation. IIoT, or the Industrial Internet of Things, where more and more devices will get connected and networked within production or in the company. And due to this increased connectivity and use of standard communication protocols, there will be a need to protect the critical industrial system from cybersecurity threats. Now, the data that we are generating will be required to be shared across sites and company boundaries. This can be done with the help of cloud technologies. The cloud refers to servers that are accessed over the internet and the software in the database that run over the servers. 3D printing or additive manufacturing is being intensively used for rapid prototyping and producing individual customized components. Most of you must have played Pokemon Go. That was augmented reality for you. AR or augmented reality allows you to add information of your visual field superimposed on the real field. These visuals are placed over the real environment. For example, in a maintenance operation, pointing the device with an AR tool, the appropriate procedure will appear in the field of view of the operator. Therefore, the operator can intervene quickly by following the information that has been displayed. Now, according to the World Economic Forum report, certain skills required for Industry 4.0 will see a drastic change over the years. A list of skills which are relevant to Industry 4.0 have been listed on the left-hand side. We can see that some of the skills which were not relevant 5 years back have now become very, very important, like complex problem solving, critical thinking, creativity. These are all very important now. So what are some of the changes that we can see with Industry 4.0? How will a factory look like? How will it work? Machines that are used in the plant will be highly automated and interconnected on a base network. The data will be collected and analyzed on continuous basis. Machine parameters will be adjusted based on quality requirements and historical data. Condition-based monitoring will be important and it will be part of the maintenance activity. Predictive maintenance will dominate over preventive and reactive maintenance. So just before the breakdown of a machine, the maintenance personnel will be informed that the machine is going to break and there is a maintenance job that is required to be done. Supply chain will get more and more efficient and effective. From the time the raw material comes to the store to the time the final product is dispatched, you will have the complete information. The production and the product will continuously be tracked. The production plans will be developed based on customer demand and inventory levels at the distribution centers and retail stores. Organization structure will become more flat, flexible, decentralized, and changeable. The production areas in the factory will be interconnected. Workers who are capable of handling data and using information technology will not necessarily be bound to a particular area like a paint shop or a weld shop, but they will be moving. They will be able to move from one shop to the other. Job rotation, job enrichment, these will be there due to increased focus on information technology. Now, Industry 4.0 is not an item that can be simply purchased off the shelf or ordered from a catalog. It requires competent industrial automation manufacturers and solution providers who are working together with the customers in order to fulfill the customer-centric markets. So for SMC, it is about helping our customers building the flexible machines that will bring about adaptability, speed, and customization. So SMC Smart Flexibility means it is flexibility in industrial networking for communicating with machines and devices, smart maintenance with predictive maintenance and condition monitoring, flexibility in machine adjustment for a quick reaction to an ever-changing market demand, and smart energy efficiency as our commitment to the environment. So let us take a small look at a small video about SMC Smart Flexibility. So as I brought out earlier, in smart factories, everything will be connected wirelessly. Everything will be on the cloud. This is a vision of tomorrow's manufacturing. The products will find their way independently through the production process. In smart factories, the machines, devices, and the raw materials will communicate and control each other cooperatively through sensors and communication technologies. At SMC, we are helping the customers to realize this dream by joining the advantages of our networking solutions to the ability of skipping the cables. Much more flexibility and versatility can be achieved with our innovative and unique wireless and decentralized network solution, the EX600W series. It is especially designed to provide high precision and great robustness for automobile body welding. Not only does it simplify the machine, but it also allows for a simple layout modification and quick connection, offering a totally reliable and noise resistant communication. So I'll show you a small video on SMC 600, EX600, how it works. So it's basically a field bus communication system where you can have all the amazing benefits of high-speed wireless communication. So there is one base unit which is mounted to the PLC and through the Ethernet IP and wirelessly communicates using a 2.4 gigahertz ISM frequency to remote units which are mounted on the machine. And one such unit can control up to 127 remote units with just one base unit. It's a very big game changer. It saves a lot of hours in setting up time for setting up the machine communication system. So here is the video of EX600. The next smart flexibility that we offer is on smart maintenance. So in the modern industry, it is not just enough to maintain, but it has to be done smartly, making more efficient use of resources and the assets that we have. Being able to analyze the status data and its change allows us to make predictions about possibility of failing in the future, and thus dramatically improving the production process from being merely preventive to becoming predictive. Monitoring, detection, diagnosis, or in 2 words, smart maintenance, is the ability to intelligently support the complete life cycle of the product and substantially enhance quality to the maximum. Flexibility in sensing and monitoring can be achieved using analog or digital pressure or flow sensors, switches, and provide you with information about what is going to happen in your production line and its surroundings. Flexibility in diagnosing through proper and agile detection of failures makes it possible to act without delay, thus increasing the efficiency and the quality. And finally, it is of no use investing time in detailed and in-depth maintenance if its implementation requires, great investment in time or disassembly of machine, for example. So therefore, it is vital that the design of a component facilitates its replacement, parameterization, and adjustment. Then we come on to flexibility in machine adjustment. So the increase in individualized products requires flexible, effective, and intelligent manufacturing, because we are moving towards mass customization, and confining machines to closed and unmodifiable changes are not the way forward. So machines must combine flexibility and quick format changes with high cycle rates and low life cycle costs. A number of our products like electrical actuators and digital gap checkers assist in achieving the goal of this flexibility in machine adjustment. I'll now show you a video on the digital gap checker. It doesn't have a background music, so I'll just explain what is happening here. Sorry. So this is the digital gap checker. It's a IO link compatible version. It uses air pressure to verify the presence and proximity of a workpiece. And applications include confirmation of raw material placement before machining or other fabrication components, other fabrication operations, or the correct seating of a component into a jig or a fixture to trigger the next assembly sequence. So here you can see the adjustment is being made using a micrometer, and once the correct seating is achieved, it gives a green signal. So it includes, ISA 3 includes features like there are two sensors to detect supply and the outlet pressure to help determine whether there is a clog or not. So there are two pressures. One is the supply pressure detection sensor and the detection nozzle, the pressure, the back pressure, which is coming from the detection nozzle. There is a calculation which is done, and finally there is an output which gives the indication of whether the correct seating has been achieved, the correct gap is being maintained or not. So that is in brief about the ISA 3 series gap checker. And finally, the approach towards SMC's approach toward energy efficiency. There are basically two commitments that we have. One is commitment to the customer and their efficiency, and the commitment to sustainability. So we work towards this sustainable development based on our 5 cornerstones. That is, generate just what you need. Don't generate extra. Generate just what you need. Recover what you generate. Monitor your consumption. Use only the essential, and think efficiently. Many of our products like air-saving vacuum generators, booster regulators, air-saving speed controllers, they help in achieve this dream. The next video on the ZK2 series, the air-saving vacuum generator, it's an energy-saving vacuum generator which reduces almost 90% of air consumption as compared to the single-stage ejector that we have originally. And it has a 50% increase in suction flow as well. And with its compact size and lightweight, it is easier to maintain. So let's see the energy-saving vacuum unit. Okay, so having seen about the SMC Smart Flexibility concept, I'll now introduce a small case study on Bosch Rexroth. How Bosch Rexroth, used the Industry 4.0 philosophy and increased their profits. So Bosch Rexroth facility at Hamburg manufactures hydraulic valves for mobile machinery like tractors and forklift trucks. The market for these valves is very, very demanding in terms of quality, strict delivery, and competitive costs. And therefore, there was a need to match this with a highly competitive production line. So what the company did was to adopt a zero failure strategy. The line was manufacturing 6 main valve product types with 250 variants and 2,000 individual parts. The line had to be flexible with small batch sizes requiring assembly parts for each product family. The Industry 4 philosophy of connectivity, while keeping the employees at the heart of the process, was adopted. So the valve production line was totally re-engineered into 9 autonomous workstations with RFID chips, which were collecting and collating the data. A technology called active assist was used, which helped the worker with steps for each product type by displaying it on the workstation. So it was an easy assistance kind of a thing. And the brain of the line was another innovation called active cockpit, an interactive manufacturing system providing a digital connection between the operator, product, workstation, and the process. It collects, filters, and visualizes manufacturing data for fast decision making. And the benefits that accrued out of this were the setup time was reduced from 450 seconds in 2014 to 0 1 year later. Inventory days were lowered in the same period from 3 days to 1.5 days, with cycle times cut from 474 seconds to 438 seconds. The stock reduction was seen up to 30% and the output increased up to 10%. And all this resulted in an annual saving of 500,000 euros. So there's a small video which shows the Bosch Rexroth plant and how they achieved it.
Bosch Rexroth exploits the advantages of intelligent, autonomous Industry 4.0 solutions. On a multi-product line at the Bosch Rexroth plant in Hamburg, 200 different variants of a hydraulic valve product are assembled economically and with no retoolings. The assembly line connects people, machines, and products. The line consists of 9 autonomous intelligent workstations. By means of an RFID chip, the product is controlled independently by the assembly line. The work steps required are displayed to employees on screens at every workstation. Modifications are not necessary. This increases productivity by approximately 10%. Kanban systems and supermarkets only provide the parts that are actually required. The result? A 30% reduction in stock. An app for fault and deviation management increases availability. All that is required for diagnostics is a smartphone or tablet PC. Each station recognizes employees by means of a Bluetooth tag and adjusts the work area to the individual's requirements automatically. Language, qualifications, and preferred font size. The Interactive manufacturing system collects, filters, and visualizes production data continuously. The employees see the information in real time and can quickly come up with necessary solutions. This reduces downtime and increases productivity. Industry 4.0 is already possible today with products and solutions from Rexroth.
So when it comes to training on Industry 4.0 at SMC, the Smart Innovative Factory or SIF 400 training system, it simulates a highly automated smart factory, including Industry 4 technologies and advanced manufacturing concepts and the reality of connected enterprises. The teaching material has been structured in 3 packs. The first is the station, which includes information on the function and operation of each station within the SIF 400 system, as well as its technical details. The technology includes information along the practical examples and integration activities which can be developed for each relevant technology. And third is the software and system, which includes information on how to install and operate the software. In addition, it also includes case scenarios and challenges in which several stations are connected to each other or work together with an MES software. Now, some of the common technologies that are used in our smart factory are industrial controllers, electrical actuators, identification devices like QR or RFID or BCR, energy saving solutions, HMIs, augmented realities, artificial vision, and so on and so forth. So these are different technologies that are used in the SIF 400. So let us see a video on the SIF 400, the smart factory, and how it works. So the SIF 400 has got 14 stations. As you can see, there are 14 stations, and you can order single unit containers, packs of containers, or pallets of packs. So multiple products can be ordered. So there are single unit containers, or it can be in a pack, or it can be pallets of packs. So this is what is being ordered now. So we go to the, once the order has been made, this is the first station, which is the pallet and container feeding station. It feeds the container and the pallets to the station according to the selection that has been made. So there can be a round container or square container. Then it goes to the second station, which is a container filling station, which fills the solid raw material in the container, and it can be of 3 different colors, either red, blue, or yellow. The second container is going for the liquid filling station. The third station is the liquid filling station, which fills the container with liquid raw material. So liquids of varying densities can be filled. Then the fourth station is the container filling with the customized product, where the container is filled with customized product like using 3D printing and so on. Again, another container is filled with mixture of yellow and blue pellets as per the order. So in different ratios, it can be mixed. The fifth station is the capping station. So depending upon the type of the container which has been selected, the corresponding cap is fitted onto the container. If it's a round container with a round cap, a square container, a square cap is fitted. The sixth station is the container warehouse for finished and semi-finished products, which can store up to 50 containers. The seventh station is the container labeling station and dispatching station. It prints the QR labels that are stuck onto the container and also dispatches the finished containers for unit product orders. The eighth station is the container packing station, which serves as a link between the assembly and the logistics station. So you can see a cobot there, which picks and places the containers in a pack. The ninth station is a pack warehouse, where the packs are stored in a warehouse. Up to 8 packs can be stored. The 10th station is a palletizing station. There is a SCADA robot in this station which it feeds and places the packs on pallets and subsequently packages them using a plastic wrap. The 11th station is a pallet labeling station which dispenses an NFC label, that's a near field communication label, and prints barcodes on them in a continuous movement. The 12th station is a pack pallet dispatching station which dispatches the completed packed pallets. And the 13th station is a recycling station where the solid raw materials are recycled. And finally, the 14th station is a IOV mobile robot which helps in transportation of various materials. And finally, SMC has incorporated the SPICE model of learning, that is SMC program for internship and competence enhancement for transforming students into smart industry professionals. SPICE has been thoughtfully designed using the vast knowledge and experience of SMC trainers, application engineers, R&D specialists, and academicians in the field of automation technology. The duration of the internship is 4 weeks, and the selection of the students is done through an entrance test. With a blended learning style of pedagogy, the intern is not only given theoretical understanding of the concepts and technologies of mechatronics and futuristic technologies of like Industry 4, cloud computing, cybersecurity, additive manufacturing. All these technologies are introduced, and also hands-on experience on our state-of-the-art training equipment, like we saw the smart factory is also provided. The various building blocks of the 4-week course includes the basics in pneumatics, electro-pneumatics, basic vacuum technology, PLC, e-learning concepts, Industry 4.0 concepts using the smart factory, concepts on quality like EHS, ISO, Kaizen, root cause analysis and corrective preventive action, energy saving concepts in pneumatics, and some soft skills like presentation and communication skills are also given. So with this, we are sure that there will be an all-round development of the student, which will give the student a competitive advantage and help in transforming him or her as a smart factory professional. So finally, before concluding, I would like to say that Industry 4.0 is poised to revolutionize the manufacturing around the globe, as did the first 3 industrial revolutions. This fact highlights the need for a highly trained and flexible workforce and production capacity that can answer the needs of tomorrow as well as those of today. Finally, I would like to quote Eric Hoffer, who said that in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. So gear up, just not to participate, but to lead. Thank you very much.
So thank you, sir. Thank you so much. A very informative session.
The video, subscribe to the channel and press the bell icon for latest video updates.